The methods to the madness. Every year, 15 million Americans attempt to choose the winners to all 63 games of the NCAA March Madness tournament. As Jeff Bergen said, people know it's a long shot, but they don't realize how long. Such a long shot that Quicken Loans and Warren Buffett partnered and promised $1 billion to anyone who succeeded in creating the perfect bracket. A perfect bracket constitutes not only picking the winner of the entire tournament, but correctly predicting which team will win in every game preceding the finals. Many people wonder why anyone would agree to giving away $1 billion of their own money on a chance, but Buffett knows that the odds are greatly in his favor. The average person's mind doesn't have an immediate or accurate grasp on how probabilities can represent real-world events, and a prime example of this is the March Madness bracket creation. People may think they know their chance at the $1 billion, but most are mistaken. Through this Matthew-mentary, we'll show you exactly what a person's odds are at creating the billion-dollar bracket, and how those odds are truly formed.
But just how unlikely are you to achieve a perfect bracket? That is, to choose the correct outcome of every single one of the tournament's 63 games. For simplicity's sake, and because the majority of the contest's 15 million entrants truly do not have any real basketball knowledge, in this calculation, we will assume that the entrant is randomly selecting the winner of each game, and thus, their chances of winning any given game are 1 out of 2. So the entrant's chances of correctly guessing all 63 games can simply be found by multiplying 1 out of 2 63 times, or 1/2 raised to the 63rd power. 1/2 raised to the 63rd power comes out to approximately 1.08 times 10 to the negative 19th power. Or in other words, that's a 1 in 9.22 times 10 to the 18th chance. Now, it's difficult to understand the immense magnitude of this number in scientific notation. So, in word form, 9.22 times 10 to the 18th is 9 quintillion. The odds of this perfect bracket ever occurring are astronomically small. So small that Mr. Buffett and Quicken Loans felt perfectly comfortable gambling a huge amount of wealth on its unlikelihood.
When the NCAA men's basketball tournament, March Madness, kicks off, many fans will try to predict the winning team by filling out tournament brackets. Now, mathematician Tim Chartier has developed a system that can beat most bracket predictions.
We beat 97% of the over 5 million brackets submitted to the ESPN Challenge.
Unlike most of the rest of us.
The way I pick my brackets is really just kind of guessing.
With more than 60 games in the tournament and 2 possible outcomes for each game, there is a huge number of different ways to fill out a bracket.
To do well in bracketology, you need to know how teams will do earlier. It's often those teams that are very difficult to predict in those games that often our methods are picking up.
The computer-assisted method takes into account such things as a team's win-loss record, the difficulty of its regular season, and its momentum. Chartier then splits up the entire NCAA regular season schedule into different segments. He chose 4 this year and decided the games in the early part of this season were not as important as those at the end of the season in predicting the outcome of the tournament. A computer algorithm then generates the top 10 teams.
So Kentucky, with today's data, is predicted to win the NCAA tournament.
This method to predict winners isn't a perfect slam dunk, but it can do a lot better than most techniques.
While the odds of randomly choosing a perfect bracket may be just under 9.25 quintillion to 1, using strategies such as choosing all the number 1 seeds to win their first game lowers the chances of choosing a perfect bracket to 128 billion to 1. Using this and many other strategies, mathematicians at Quicken Loans found that the average person had a 1 in 80 billion chance of creating a perfect bracket. If you factor in that there are 15 million entrants to the contest, they discovered that there's a 1 in 5,300 chance that somebody out of the 15 million would create a perfect bracket. If you consider this and the fact that a perfect bracket has never been chosen before, then you can understand why Buffett put up the $1 billion wager. Because of the 1 in 5,300 chance of somebody winning the bracket, Buffett decided to charge $1.87 million as his premium to Quicken Loans. He decided on this number because if the $1 billion was won this year, using the 1 in 5,300 probability, Quicken Loans would have to pay Buffett $187,000 every year for 5,300 years in order for him to get his money back. While $1 billion may be a very large amount to insure, Buffett decided he would bring up the calculated premium of $187,000 to $1.87 million, so that he would have his money back in 530 years instead of the quoted 5,300 years.
So if the odds of winning are so slim, why do entrants feel as if they even have a chance? The answer is that people generally have a very weak concept on how probability works in the real world. Oftentimes, the human mind makes assumptions on the probable outcome of an event, which are very different than the actual calculated probable outcome. Take, for example, the famous Monty Hall problem. A contestant on a game show is given the choice of 3 doors. One door holds a car, while the other 2 hold goats. You pick a door, say number 1, and the host, who knows what's behind the doors, opens another door, say number 3, which has a goat. He then says to you, do you want to switch your pick to door number 2 or stay with door number 1? Now, should you switch doors or should you stay with your original choice? Or does it even matter? And the answer, contrary to natural human intuition, is that you should always switch doors. In fact, switching doors yields a 2 out of 3 chance at winning the car, while staying with your original choice yields only a 1 out of 3 chance at the car. And just as most contestants in the Monty Hall problem don't have a firm grasp on how probability affects their decisions, most contestants in a March Madness bracket tournament don't understand how small their chances of winning are and how using calculated probability can help them win. Those who do understand how probability affects the real world hold a distinct advantage in these types of contests over those who do not.
Commonly used throughout our everyday lives, probability has a wide variety of applications. In order to understand how probability affects various aspects of our lives, one must be able to distinguish between 2 classifications of probability: permutations and combinations. A permutation, in which order does matter, represents all possible ways of doing something. A combination, in which order doesn't matter, represents all possible groups. The odds of winning the NCAA Bracket Challenge must be found with a permutation, because the order of the team's wins matters. This is because the winner of Team A versus Team B must be decided before the winner of Team A/B versus Team C can be decided. Not only must one choose the exact winner of the tournament, they must also choose the exact path with which each team will take throughout the tournament. This is part of the reason why the odds of achieving a perfect bracket are so incredibly small.